Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, Headroom, a project tackling one of the biggest pain points in AI development, the massive cost of LLM tokens. It compresses your logs, files, and other data before they reach the model, promising to slash token usage by up to 95%. The incredible part is it achieves this while still getting the same high-quality answers, making it a potential game changer for developers everywhere. Imagine feeding an AI agent massive logs, tool outputs, and files, but paying just a fraction of the usual cost. A new project claims it can slash token usage by up to 95%, all without hurting the quality of the answers. This is the promise of what's being called local first context compression. That project is called Headroom, developed by chopratejas. At its core, Headroom is a context compression layer for AI agents. It works by shrinking tool outputs, logs, and files times before times they ever get sent to a large language model. The goal is to dramatically cut API costs and get around those pesky context window limits. And it seems developers are paying close attention. The project has exploded in popularity, gathering over 6,300 stars on GitHub, with an incredible 1,200 of those stars appearing in just one day. That kind of growth signals some serious interest from the community. So, what's the core problem Headroom is trying to solve? Anyone building with AI agents knows this pain point well: cost and context. When you feed large amounts of text, like server logs or big API responses, to an LLM, it gets expensive fast, and you're always running up against the model's limited context window. The old solutions were not great. Developers would either have to cut off their data, which risks losing critical information, or they'd have to write custom summarization logic. That second option is not only time-consuming, but also fragile and hard to maintain. Headroom offers a more systematic solution. It provides a dedicated compression layer that intelligently shrinks the context times before times it gets to the LLM. It tackles the problem at the source, instead of treating it like an afterthought. Let's dive into how Headroom actually works. Its design is centered around a concept called intelligent, reversible compression. When data flows into the Headroom pipeline, a component called the content router takes the first look. Its job is to figure out what kind of content it's dealing with. From there, it sends the data to a specialized compressor. For structured JSON, that's the smart crusher. For code, there's a code compressor that works with a program's abstract syntax tree. And for everything else, it uses a custom model for general text. This is way more sophisticated than just simple summarization. But the most innovative feature is something called reversible contextual compression, or CCR. Here's the clever part. Headroom compresses the data, but it also gives the LLM a special tool called Headroom Retrieve. It's like giving the model a library card. The LLM gets a concise summary to read first, but if it needs more detail, it can use that Headroom Retrieve tool to check out the full original document from local storage. This design brilliantly balances efficiency with data integrity. On top of that, a cache aligner component works to stabilize the beginning of prompts. This improves the chances of a cache hit on the LLM provider's side, which helps reduce both cost and latency even more. So, who is this for in the real world? The primary users are developers and engineers who are already leaning heavily on AI agents. For example, a site reliability engineer could use it to compress massive incident logs before asking an LLM to pinpoint the root cause. Or, a developer building a retrieval augmented generation, or RAG, system could fit way more retrieved documents into the context window. What's really compelling is how easy it is to get started. The barrier to entry is remarkably low. You can integrate Headroom as a simple Python or TypeScript library. Or, you can run it as a proxy server, which requires zero changes to your existing code. Even better, you can instantly wrap popular coding agents like Claude or Cursor with just a single command in your terminal. This level of flexibility makes it incredibly accessible for a wide range of workflows. Looking at the community, the early feedback is overwhelmingly positive. Users are confirming that they're seeing significant token savings, often without any noticeable drop in the quality of the AI's answers. The ease of integration, especially using the proxy and wrapper commands, is a point that comes up again and again in praise. Now, while there are not widespread negative reports, some developers are raising valid points. They are asking about the added complexity this might introduce for debugging. Another concern is the system's reliance on the LLM to be smart enough to use that retrieval tool correctly when it is needed. But despite the clever design, Headroom's success is not a sure thing. Let's consider a contrarian view. The entire reversible compression model depends on one critical thing: the LLM's ability to know when it needs more detail and to use the retrieval tool correctly. If the model fails at that, it could lead to subtle but serious errors based on incomplete information. There is also the issue of latency. The local compression step, by its very nature, adds a small delay. For real-time applications, this could become a significant bottleneck. And looking at the project's roadmap, the plan to migrate key components from Python to Rust suggests a complex technical journey is ahead. They are essentially trading some of today's simplicity for better performance in the future. In the end, Headroom offers a pragmatic and deeply technical solution to the ever-growing cost of LLM context. Why does this matter? Because it fundamentally shifts context management. It takes it from being a headache that every developer has to solve at the application level and turns it into a reusable piece of infrastructure. This simple but powerful idea could make building powerful, data-intensive AI agents more economically feasible for everyone.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.